So 3M, lesson 6, we're going to look at the different forms today. You're now experts on quadratics from beginning to end. And we're going to see what we can glean from each form when we're looking for things like the y-intercept, the x-intercepts, the axis of symmetry, the vertex, the direction of opening, and a sketch. So for the first one, what information can you get from each of the following equations without changing forms? So the first one has no brackets anywhere in sight, so I know that it is in standard form. Standard form is the most helpful when you are coming up with an equation, say in science, and you have all the coefficients given to you in this form. It has no brackets. Then trying to graph it and glean information might take us some work. So y equals x squared minus 2x minus 24. The only thing I know for sure is that it opens up. Normal step pattern, because there's an invisible 1 in front of the x squared term. And I know in standard form the last number is the y-intercept, because if I were to substitute a 0 in for x here and here, the only thing left standing would be the negative 24. So standard form gives me my y-intercept. Since I know that it opens up, I am not sure if it's going to open up this way or if it's going to open up with the vertex over there. I don't know, but I do know this point, and I do know that it opens upward. If I have the second one, what do I know without changing forms? X plus 2 squared subtract 4 is in vertex form. What do I know without changing forms? Well, I can see that there is an invisible 1 for my a value. Like the last one, it opens up. It has a normal step pattern. Okay, direction of opening, so I know that. For vertex form, I know the vertex. The h and k values hiding there, so I know that I have 2 to the left, down 4, careful. Anything in brackets is backwards to what you might think. That also tells me the axis of symmetry. The axis of symmetry is that middle, like a line really, that runs down the middle of the parabola right through the vertex. And we could write it as an equation as x equals negative 2. I could sketch this thing. I'm kind of jumping all over the place, aren't I? I could sketch this thing because I know where my vertex is and I know my step pattern. I could draw this fairly easily. So my axis of symmetry is at x equals negative 2. That's like my fold line. I know my vertex is at negative 2, negative 4. And I know it opens upwards, regular step pattern. So I don't have a very accurate grid, but I would have over 1, up 1, over 2, up 4. And I have a sense of what this looks like from vertex form. So what else am I missing? My y-intercept and my x-intercepts. Well, I know standard form gives me my y-intercept easily, but I do know for my y-intercept that it's going to be a point that looks like that. So if I would substitute x equals 0 into the equation, I could find my y-intercept. So let's go back to my equation, and I'm going to put a 0 in for x. Well, I can do that. I'm going to do brackets first, so order of operations, brackets is 0 plus 2. Then I do exponents. 2 squared is 4. And lastly, 4 subtract 4 is 0. So for my y-intercept, the y value is 0. So I have figured out almost everything without changing form. The last thing is x-intercepts. Well, we can do that. For my x-intercepts, my y value is 0 because I could potentially have two x-intercepts and they both look like that. So to find my x-intercepts, I'm going to substitute y equals 0. Let's see what we get. I'm going to just write down here though. I put y equals 0 for my equation. I have 0 equals x plus 2 squared plus 4. Subtract 4. Sorry. Okay. I would like to solve for x. I am going to add 4 to both sides. So my next line will be 4 equals x plus 2 squared. I'm kind of undoing this, unpeeling it like an onion like we did before. I want to get x by itself, so I'm going to get rid of the square next. To get rid of a square, you would take a square root. But remember, you could have a positive number squared gives you an answer, and a negative number squared gives you an answer. So I have to think about the positive or negative square root of 4. Last thing I'm going to do is subtract 2 from both sides. Okay. I have two x-intercepts. The first one is positive root 4 subtract 2. The second x-intercept is negative root 4 subtract 2. Let's do the first one. Square root of 4 is 2. Positive 2 subtract 2 is 0. There should be an x-intercept of 0. Yes, right on our graph. Let's look at the second one. The second one is the negative of the square root of 4. Square root of 4 is 2. And negative 2 subtract 2 is negative 4. Got it. So in this form, vertex form, we found every single thing without changing forms. The x-intercepts were a little tricky because we had to solve, but the rest of them we could find with no problem at all. Whereas standard form, we could find fairly little unless we're willing to change forms. Let's find the y-intercept, the x-intercepts, the axis of symmetry, vertex, direction of opening, and sketch without changing forms. This is in factored form, the last possibility. Do you think we can find everything like we did on the last one? Okay, what's easiest to find in factored form? In factored form, the easiest thing to find is the x-intercepts. Your x-intercepts would be positive 1 and positive 7 in this case. The next easiest thing to find would be the axis of symmetry. The axis of symmetry is that axis line that runs between the two x-intercepts and has the vertex on it. So in the middle of 1 and 7 is your axis of symmetry. Well, if you can't figure it out by looking at it, we can take our x values and average them. So 1 plus 7 divided by 2 is 4, would be your axis of symmetry. next thing to find would be the vertex. We know the vertex is on the axis of symmetry, so its x value is going to be 4. Now I know this one opens upwards actually, so I know my vertex is down in this bottom quadrant somewhere. If I want to find the exact value of the vertex, I'm going to need to substitute x equals 4 into the equation. So I'm going to put a 4 wherever I had an x. I have 4 subtract 1, 4 subtract 7. 4 subtract 1 is 3. 4 subtract 7 is negative 3. Weird. Negative 9. So 4, negative 9 is my vertex. Okay, what are we left with? The direction of opening is that A value. I guess that really would have been the simplest thing, wouldn't it? Number 4 opens up. They all have that first value at the beginning. Tells you whether it opens up or down, a stretch or a compression. This one has an invisible 1, so it opens up. Sketch, we could do that once we found the vertex. And lastly, the y-intercept. The y-intercept I can get because I apologize. Number 5, y-intercept. I know a y-intercept looks like that. I know it comes easily from standard form. But if I know the x value is 0 for the y-intercept, I can substitute x equals 0 into the equation. So I am going to put a 0 wherever there is an x in my equation. So 0 subtract 1, 0 subtract 7. My y-intercept will be negative 1 times negative 7, which is positive 7. Does that make sense? And well, mine didn't curve the right way, that's why. This is so lumpy, it's so frustrating. Okay, I'm going to try and hit 7 like I mean it. There we go, 7-ish. Anyway, the other side looks uneven now. And I would never take that from you on graph paper. Anyways, let's work on that chart that I have for you in your handouts, where you're gleaning the information where you don't have to change forms. You're going to fill out all of that you don't have to change forms for. We'll work on that together.